Good afternoon. Welcome. Thank you for turning up at 5 o'clock on the Tuesday. That is a good effort. I appreciate how that feels after a long day of walking between venues. I'm going to talk to you today about proactive security testing in AWS. The main goal of this session is to walk you through how we think about security in AWS, how I personally think about security, the mechanisms you can use to get yourself into a better shape ahead of launching services, and what you can do to maintain that in an automatic way. So, what to expect? I'm going to spend the beginning of this talk explaining threat modeling to you, explaining why I think that's a very, very, very important piece of any security story. Some of you may know this already, and I will hopefully put a new spin on that for those of you who already know it. I'll then focus much more on demo-oriented content, diving on the services, what you can do, show you several proof of concepts and code snippets to use. And then I'm going to bring that together and talk about the continuous aspects of security and how you keep it built within your services. Okay. Firstly, can I get a quick show of hands of who knows what threat modeling is? Okay. It's a good number. But the main reason I wanted to ask that is the number of people who think they know what it is, who don't do it. So, okay, how many of you, next show of hands, know what threat modeling is, but actually use it within your business proactively? That's a shockingly small number of hands, just for good measure. Okay, it is extremely important. We use it extensively in AWS because it enables us to have a conversation between the service teams, the people building the products, and the security teams or vendors outside the company. It's one of the mechanisms we believe is extremely important for building a sense of your risk and what residual pieces need developing as features of your product. And so we think it's an extremely important activity. It will help you understand what your external dependencies are, what assumptions you have made, why do you have these kind of external pieces that you are using, what are those pieces that would be able to break your service if you weren't using them effectively. It will also help you understand what the edges to your system are. Now, the edges to a system are extremely subtle, especially in a cloud and infrastructural capacity where we can stand that up with an API very quickly. So those edges are very different to your traditional edges in a more legacy setup in a data center. So I'm going to hopefully help you understand that and walk through that somewhat. Assets, information flows. What are the key things that matter to you in an application? Where are you making decisions? How do you do that? Who are the users within your system? And that's usually quite a subtle question. And usually it's much bigger than you think it is. And what are the kind of trust aspects of that you are using? And then draw that to a kind of risks and mitigations conversation before I then swap over into demos. Okay. What is an asset? An asset is anything where you are going to store information or make some form of decision on the basis of that. So in itself, a computer or an instance is not really an asset. It's what's running on the instance and how you're using that asset that is the key piece of that. An S3 bucket isn't an asset, it's the information within it. But the asset value of an S3 bucket is how you control the access to it. And so this is how you should start to kind of walk through your system. What are the primary components? How do they exist? What do they do for your users? Access management is a subtle thing. We have the ability to add users within our systems. But actually, in a cloud context, there are lots of different categories of access management. We have the IAM, the Identity and Access Management Services, is one type of user. But you've also got all the additional users that exist within your application itself. And they may well be a completely different source of trust. And so you start to get into this case of, okay, access management is now multiple facets in my application. What about the networking? In a cloud context, I can stand up networking to do different things. And the people that might do that are a different class of users, perhaps the people developing the applications. Those are also people that can genuinely affect your application. And so it's there to help you focus on this model within your threat model. One that nearly everybody forgets, And for a lot of people that I've spoken to outside of AWS, this one is classically the new conversation in most threat models. How are you doing deployment, and how are you doing development? Where are secrets managed? Because if your devs have access to all the secrets for your production environment, that, by the way, should be in your threat model. Something you should work on, risk, and mitigate. You know, normal stuff. Okay. Users. We have lots of classes of users. We have the standard types of users, the people using your service. But what about services? We have interdependency on services. What about all the social media services you're using? If we kind of link into all the kind of other types of social media that exist, they also have API accounts. And what about the ones that can call back to your service, or if you're using them as an authenticator, for example, which lots of people do, you have OAuth setups, things that call back to you. Those are also interdependencies that feature within threat models. Access to shared assets. What happens when you have a database and multiple users of the database, not just the constraint within your application space, but people that are getting that from somewhere else? Again, this is to try and help you think about it's much wider than you might traditionally have gone with. So, I'm going to start with a really basic threat model to kind of generate the conversation and show you a little bit more about what I mean. Now, there are lots of different versions on the internet of how to do threat modeling, so do not take this as the verbatim only way to do it. The most important thing I'd say about threat modeling is what suits you, not what suits me, the speaker. But the key is to get you thinking about this. So I'm going to start with a very basic web server running a content management system application. Yep. And so most people, when you start, you ask the architect in that conversation, so draw me what your application looks like. And that's about where they stop. It's like, we get some boxes and some arrows, and that looks kind of cool, right? And we can walk away. Well, okay. So we start adding some users into the system. And so most people are pretty good at understanding that we have somebody who isn't authenticated and somebody who is authenticated, and they can do different things on your system. So good. You've got the people to write the next thing. And you say, well, okay, well, who manages your system? And they go, oh, I guess there's a couple of people that manage the system too. Okay, yeah, we've got a web admin guy, and we've got this kind of idea of a DBA. Yep, they do all this stuff. Okay, good. Now what about the marketing folks who can pull the data from that application on the back to get all the kind of useful integrated reporting that we need? Oh yeah, those guys. So, okay, we added another person in here. And you can imagine how this can go on for a while, and you suddenly start finding this great sort of almost a web of users around your application very quickly. But in threat modeling, the next thing we do is we start to draw the flows between the users and the assets within the system. And we label those flows, and we start to put things within there. Now, again, I've cut this model very simple, and this is not a definitive list of flows in this application. This is enough so I can have a conversation with you about threat modeling, not to judge me by how definitive a threat model this is. Just for care. So, the last thing you do in a threat model is you draw the trust boundaries. And the trust boundaries are any place you're going to make a decision. Any place that you're going to make something that could make some form of trust decision, some way that you might elevate the privilege of that user. So if we look at the flows that I have here, I'm going to log on to a machine. 1.1 is the logon flow in that top left. Of course, I'm about to change the privilege of that user. That user is going to go from an unknown user to a known user. That's a clear trust boundary. Likewise, an authenticated user is going to post something to the system. It's a CMS system. Of course, they're going to post to the system. We need to understand they actually have the rights and the privilege to do that. They may not be able to post to all aspects of the site, for example. They may only be able to post to their area of the site. So again, we have a trust boundary. Likewise, any administrator is going to cross a trust boundary. Are they able to admin these aspects? And this last person is going to do that. The other one, you can see the blue dotted lines in this diagram. What about the inter-service trust aspects? If I'm going to go and call a caching server, how is the web server authenticated to the caching server? How is the web server authenticated to the DB server? Those things are also trust decisions. You've got an aspect of where are those secrets going to be stored? Do those connections need to be encrypted? You can begin to see how a threat model will allow you to ask those questions. And that's why we do this process. We can step through it and discreetly handle where we need to make decisions. And importantly, track, did those things actually get implemented? which is kind of an important thing. So for those very small number of people that put up their hands on, yes, we actually use threat models, this is why we care deeply about threat models inside AWS, and I hope you guys get to care about them some more too. So, in order to prepare you to show you how you go that next stage on threat models, hopefully a good chunk of you will have heard of STRIDE before. This is how we can explain risks within a system. And this is a really high-level category of what the risk is within a system. So, what is spoofing? Yep. So spoofing is any way in which we can make something appear to be different to what it should be. Yep. And again, it's a sort of general class of risk, and we talk about this a lot, and you will hear security people talking about spoofing. Tampering. Can I change the information, even subtly, on a wire? So an example of tampering may well be, yes, I'm going to grant access to this user, but if it's going through something I control, there's no control of that, and I change who the user is, I've tampered with it on the wire. What about repudiation? Now, repudiation is one of those words that confuses a lot of people. It really just means effective logging, understanding the actions they took, such as you cannot deny them later. Yep, so most of the times repudiation systems is very effective logging and activity monitoring. Information disclosure. We've seen lots of this in the press. Lots of people know what information disclosure is. But this is any case where the system gives you something it shouldn't. Maybe it gives too much information, but that would be an information disclosure risk. Denial of service, loads of people know what denial of service is. I think everybody in this room has probably heard of that without me asking for a show of hands. And the last one, and probably one of the most important ones up there, is elevation of privilege. If you have a risk within your system that isn't mitigated for elevation of privilege, it means I can become somebody that I'm not supposed to be, or I can do an action that I am not allowed to do. This is one of the key ones, and probably the area that most people care most about when you ask them to explain what scares them on their systems. However, the remainder of those risks can have very serious implications. If you are somebody advertising in the Super Bowl and I deny the service of your website, that is a very, very, very serious problem. And it can be just as much of a problem as something else. So these things matter to different people at different times, and somebody's idea of risk and their risk bar is going to be different. So we just have the terms to classify with. In this next slide, I'm going to show you how we would do this as a conversation. So the 1.1 was the login flow. We've labeled that up in a document. No, I do not expect you to read every single word in here, but the idea is I'm trying to show you how you would then label these flows up, and then this will enable you to have a much richer conversation and also design your security testing in something that actually matters, rather than, yeah, we did some security testing. What did it buy you? So you walk through the risks of the system. So this is the login flow, and you describe what it is. What is the risk in the login flow? Well, an unauthenticated user could log on to the CMS if we get it wrong, in effect. So what's the spoofing aspect of that risk? Well, a user might not be checked properly and therefore be able to do something under a different identity. It's one risk. What about repudiation? Well, if I don't actually log the attempt to log in, so if I don't have the failed login attempts and the successful login attempts, if I have any problem later, I'm not going to know what happened. So it's kind of key that you have repudiation within the system. That's really important. What about denial of service? This one's kind of subtle in a login flow, but if you think about it, I'm going to take some form of credential from somebody. I'm going to compute something on the basis of that credential. So in the case of a password, I may well hash that password and compare the hash. Or in the case of I've got a multi-factor authentication token, I'm going to go and broker this to someone else to ask a question. But if that process is computationally expensive, if it becomes a couple of orders of magnitude more than the normal flow of something, there are lots of problems that can come from that, because I can start calling your login functions extensively and take the service down. So that matters. Elevation of privilege is kind of obvious in a login flow. I get it wrong, I become somebody I shouldn't. Okay, so I've explained the risks. Now what do I do about the risks? Again, this is not exhaustive. I tried to fit it on a slide, so please don't judge me too much on that one. But what I do is I walk through each of those risks that I identified before. I take a feature that is trackable within my feature tracking. So if you have it on Kanban cards or if you track it in your Scrum system, whatever it is, each of these security risks should be tracked as something for you to implement. Because later you can come back to it and say, yes, I have actually done this. Kind of a key one. This should be as much of a living document as you can possibly make it. Because that living aspect of the document means it becomes something you keep updating. And if you actually have a good series of developers within your organization, you can have fun with this and play a game where anyone who identifies new risks gets a gift voucher, or I buy them a beer, or whatever your favorite way of doing it in your teams is. But it becomes a really good way of making sure that everyone's bought into fixing these things. So I talk about everything in there from addressing spoofing concerns by code review. Well, okay, how am I going to do the code review? And importantly, once the code review has happened of this, how am I going to stop new issues coming back in? So that's the first one. Logging using CloudWatch logs, for example. We've got that in there. Well, how about alarms for failed login attempts so that actually I can respond to this stuff? And so as you kind of go through this, you start thinking about, okay, I can implement these features that will enable me to sleep better at night. I've got better operational understanding of my system, and the features are built in. That way you're not trying to build them after the fact when you've gotten a problem and go, oh no, I knew I should have done that. This is trying to get you ahead of that problem. So the denial of service one at the bottom, the best way to do that is a lot of profiling, a lot of understanding of your service, or another feature you could have auto-scaling to give you horizontal build-out if you go beyond a certain capacity. You've got different things that you can do to respond to the issues. And so this is helping you have that dialogue so that as you come to your testing, you've got actual things to test. Did I do this? Did I not do this? Okay. So in a traditional AWS system, that blob in the middle is our CMS again. What I've shown is how most people have thought about it, and I'm going to build around, okay, how you should really think about it. So in that diagram, I had a database server. We're going to put that in a private subnet, general reasonable design. I'm going to have VPC endpoints inside my public subnet perhaps, or even my private subnet, depending upon how I want to have that for my S3 buckets, my Elasticache. Okay, this is usually the people who then walk away and go, okay, I've described my system. But actually, what about the network? In AWS, we have VPCs. We have internet gateway devices. We have route tables. Who controls those? How are they configured? That's an external dependency on quite a lot of people's systems. So it should feature in your threat model as something that you've taken into your system that you need to understand and how you're going to work on it. What about the IAM users? If you have an instance with an instance role, so let's say I've given my web server privileges to call these other things, then how is it managed? How does it work? What about DNS? Most applications that you have need to be reachable by a name. Who's managing it? How does it work? Again, there's a dependency in your system. If you've got CloudFormation templates that built this, who manages those? Where are they checked in? Who can change them? How does it work? Again, all risks that you need to consider in a cloud context. KMS. This one's kind of an interesting one. It has a bit of a duality. If you are using KMS, who's managing it? How is it working? If you're not using it, it's a way of solving a problem of yours, which is how do I move secrets around my system safely and only give it to the instances that should have access to the secrets? So it can solve a problem, but it's also something you should work on how you manage. And then I mentioned these other pieces because they are good practice. You can use config to track how things are changing over time, CloudTrail to look at the API calls, and then Amazon Inspector to actually manage how we're doing of findings within your system. And I'll cover a demo of Inspector as well during this to show you how we would use that. At the heart of this, we'll have built a security baseline in the end. You'll have done all this effort, and in the end, you will have a baseline that will have a number of things that you will be able to test against. We will have some form of controls, and then we'll have a number of things that we want to make sure that we are knowing about. So if you think about it, well, what ports should be open on the machine? What services are supposed to be running? How is this going to be something that I can make sure is what I expect it to be? And that's what we'll have spent all this time building up, is this kind of this baseline thing. at the heart of it, you're trying to build something that you can test for, have I successfully dealt with that risk, or do I still have it open? Some of those things are I've implemented the feature. Some of them are actually testable by trying to talk to a port, or by being able to pull part of an application, or being able to do these things within the configuration. Okay, I'm going to kind of kick over to a first demo. So, one of the things very few of us have the privilege of is inheriting a totally clean slate. Yeah, exactly. So very, very, very few people get the benefit of being able to build an application that doesn't have some form of existence before we got there. So something that you'll have is whether you are going to do this over the lifetime of an application or whether you're going to inherit it, is okay, what outstanding security patches needs to be applied to a machine? Fairly reasonable thing to ask, yet surprisingly challenging to actually answer. So quick show of hands, depending upon how, this is going to ask me how much I need to explain it. How many people have used the EC2 command? Okay. This is something that came out not so long ago. It's part of the Simple Systems Manager piece, and it's a very powerful little tool. So I'm just going to sort of show you how we can make use of this. So, hopefully, I'm going to introduce some instances that will become used through the rest of my demos. So, if nothing else, if you've heard of it before, pay some attention because I'm going to introduce some instances which are part of this. I have 2 web server instances, and because I want to make sure that I'm being fair, I have a Amazon Linux instance, and I have a Windows instance to try and show parity between the 2 in this case. So, my first web server instance running Amazon Linux, as you can see, I'm just going to have a look at that, and then I got my Windows instance there. Now, we're going to move over to running a command. And you can see a list of several commands which you could possibly run. Now, quite a few of them are Windows orientated because there's quite a few built-in PowerShell things that can be called in Windows. And the first one that we're going to go into is find Windows updates. Kind of well-named, let me know what the current available updates could be for Windows. We select the instances to run here. It's smart enough to know that Windows programs should only be run against Windows instances. We can put the outputs into an S3 bucket, and we can notify you on the basis of how it works on a series of events. So you can have a set of asynchronous activities going as this runs. Although I'm walking through this in the UI, this is very much something you can also do from the command line as well. And so for a lot of the continuous integration pieces, that's really where I'd be suggesting you go. But for the sake of a demo, I'm showing you this running. We run the Windows instance, check, and then we actually look at the output to that. Okay, so this returns successfully, and the output on this instance is one thing needs installing. And this is a Windows Defender update, which, although very important, is not the same as a critical operating system vulnerability. So this Windows instance actually is not too far off the patch that it should be, which is good. Now we're going to do the same exact thing with the Linux instance. We're going to run a shell script in this case. Now, when you're running shell scripts on Linux, you need to know what commands you're actually going to run in this case. We haven't got the same automated set of documents. We select our Amazon Linux instance. Now, in this case, we're going to use the sort of check updates part of the yum command with security. This particular command returns a non-zero, so non-success state if it finds patches. So I add an echo command underneath so it returns a success if we ran all commands. That's kind of a key one for knowing how the commands work on Linux. So if you're wondering why I added echo done, it's so that we have a 0 return if everything executed properly. Okay. Having done that, we're going to step on to run that now. Okay. And so in the same way, we're going to look at the output of that command. The 0 response code was important. Otherwise, when you are tracking this via APIs, life gets harder because it looks like the command failed. And you can see there are 6 patches that I need to install. Okay. So this is how you can easily establish where you are. The other part to this is there are documents which you can build for everybody else to be able to use. One of the reasons why that is a good thing, if you take the Linux case in particular, let's say you have multiple types of Linux. Let's say you've got a little bit of Amazon Linux, a little bit of Ubuntu, maybe some other distributions as well. The commands to know whether you need to install patches vary by platform, because if your package managers are different, they're going to be different commands. You can build the shell scripts that would work on multiple platforms and be agnostic, and if you're a systems administrator perhaps, you could put that in the document and have other engineers run that, and so manage those two things separately. It's a good separation of duty. So the documents are very, very, very helpful for that. Okay. That one's not the most interesting example I could show you though. So I'm going to step into some more, in my opinion, interesting examples. So about building security. Well, obviously people are developing code. They build the code, they check it in, but how does that look in terms of your security profile? Are you able to make sure that what you have in terms of your source code is at least baselined at some level, isn't going to get worse than it was the day before? If I spend my time fixing things within the code, how do I guarantee they don't come back? Because guess what? The same mistakes will happen unless you've got some way of baselining the stuff. So this is about sort of enabling us to do some form of static analysis on some form of central repository. What are the triggers within here so that I can go and do that analytics dynamically? How do I work on the staging and pre-deployment pieces? So I'm going to show you using AWS code commit to do this exact thing, to give us some form of check on the source code. In this case, I'm going to show you a very, very, very simple check. But although that check is simple, this is a piece of building block that you could use to implement your own business logic. There will be things unique to each and every one of your businesses that are sensitive to you. And so these kinds of techniques are things that you can reuse with your own variations on this demonstration to protect your assets. So let's have a look. So first we step into code commit. I'm going to show you a demo repository that I have. And at the moment, it has exactly 3 text files in it. Not exactly the most carefully developed repository in the world, but the reason that I put them there is so you can see that I'm not cheating in a minute's time. So first we create a trigger. A trigger is something that will respond to an event on the repository. So I create a new trigger, and I give it a name. Next, I select the events that I'm going to respond to, and the only event in this case that I care about is when I push to an existing branch in the repository, I want you to call this SNS topic on my behalf. Normally, you might put that under a branch that matters to you, such as a central integration branch. Everyone's personal branches may not be touched, that kind of stuff. But it's up to you how you work as a business. I push this to SNS rather than directly to Lambda because the way in which static analysis may take more processing time, may require specific hardware requirements to work. But again, you could push it to Lambda as well to respond to events. And then I go to an SNS topic that I've already set up called code check. I also have an SQS queue that listens to that topic on the back of it, configured with the right permissions. I'm going to assume in this audience you know how to do that, but if you don't, I'm very happy at the end to explain that to you. So I've jumped a step, but I assume that people have done SNS and SQS before. Okay, now I have that trigger set up. On my developer box, see that's the repository proving I'm not cheating. I'm now going to edit a file after I make the directory to put it in. Okay, so I have a very canned example of using S3 in this case, and I don't bother to develop it fully. But what I want you to see there is that I create a normal client, and then I deliberately pass in secrets to that client that I should not. Yeah, that is very, 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 very bad practice, and if I can't say it strong enough, do not do this. But some of you will, no matter what I say. So, don't, whatever you do that. So I now add it to my local repository tracking. So this is a file, and I'm now going to make sure I'm tracking it in the normal way with Git. I then commit it to my local repository. Now Git works by me storing that file locally first, and then I push it from my machine up to a central repository. Okay? So although I'm committing this to what would look like the repository, it's only on my local machine. That has not left my machine yet and gone to the central repository. I'm now going to swap over to the code checking machine that's going to be on the end of that queue, and I'm going to show you what's going to be on the other side of that queue. So here I have a code checking machine. It has a single file in here in Python, which I'm going to walk through during the demo. Don't worry if you don't understand Python. I'm just going to I'll explain it in broad terms, and hopefully in the slides you'll see enough of it so you can really grok it later, or grab me at the end and I'll explain it in more detail. And I start this thing listening for push events. So this is now recurringly pulling on the queue, periodically polling. Going back to the developer machine, I'm now going to push this file to the central repository. So it's now going to leave my developer machine and end up in the code commit repository. Okay, and up it goes. And as you can see, that has gone to the code commit repository. Just to prove that's actually happened. If we swap back to the code checking machine, we can now see that we received the event. I print the whole event out there just to show it really was an event. No cheating there. And as you can see, we found an AWS secret within that file. So we pulled everything from the repository, put it on the machine, we ran through all the files, and we looked for something that we should not have. You can make this flow an awful lot more complicated, as you can almost certainly figure out. But stepping through the code, so I can show you how you actually do this. The first thing is when we look at the main function to this, we just have this listen for commits loop. So down the bottom there, you can see I'm just doing a loop, listening for any of the events that come to me. Really simple stuff, nothing crazy difficult here. Next thing, what do I do as I see this loop? So after I start that, this is really where this kind of connection to SQS happens. I start pulling for events, and I go into this infinite loop, listening for them. Once I get a message from there, you can see I clone the repository, and then I check against the rules that I have. So again, written to work with new rules. You could write your own rules for this. Cloning the repository, I use the Git Python library to make this easy. This is an easy way of pulling it. That uses the setup on my machine to do that. So I've set that up on my developer and my code instances. And then checking the rules, I just step through every file apart from the ones in the Git directory, because clearly there's no point doing that. Look through each of those files, and then check the file for something within my rules. So in this case, check file path just runs a regular expression looking for a very specific thing. You can make this a lot richer. You could build abstract syntax trees. You could do all kinds of crazy fun stuff to look for very, very, very good bugs. But this regex here is very simple. We look for the words AWS secret access key, any number of spaces, and the equals sign. And that will trigger this rule. But in your case, that may well be licensing violations. It may well be you look for text to do with a license that you don't like within your company for libraries that you're using. It could well be that you look for other types of secrets that you build in. But if I have more than one match, if I have more than 0 matches, sorry, then I'm going to report this and all the lines that I see this on. But hopefully this will give you some idea of how you could use a technique like this to build much richer things that are specific to your needs and your environment rather than my needs for you not to use secrets within your source code. Okay. Hopefully that one's helpful. What about deployment assessment? So now I've shown you how that works for source code. Each time you learn something, a mistake from your source code, build in new rules, by the way. You want to keep your levels good. But for deployment, well, okay, let's look at this. I'm going to use Amazon Inspector here to look at some instances that I have pre-launch, yeah, and see how they work, and then check them. If they pass criteria that I have, I'm then going to move them from that criteria into a launch criteria, whatever that is, and I'll explain that in a moment. So, We're going to revisit our favorite instances and have a little bit more of a look at them so that you can understand what I'm trying to do here. So, the web server instance has two security groups. A secure shell group that I can reach, and a web VPC only group that I can reach. That web VPC only group is configured so that only within my VPC can I talk to this web server. It is not on the internet. So if you think about something like Inspector, you're going to test the application as well at some point. There's a tag here which is about staging rather than production, and the web server tag shows you that's there. For the Windows instance, the same thing. I have a staging tag and a web server tag, which I'm going to use to identify these later. And next, we're going to try and connect to those. So, we step across. Okay, so in this example, I've used curl to try and talk to those instances, just try and pull a GET request to them. And you can see that I've put deliberate timeouts in there, so this doesn't spend about a minute's worth of your time being bored looking at a screen. And what I'm just proving here is those security groups are working, so they are not allowing you to talk to them from the internet. Yep. So again, these could be tests that you implement. They're very, very simple tests, but they are yes and no tests that are reasonably part of a threat model. Next, I'm going to use Inspector. Now, when you've not used Inspector before, you configure the role, you step through all this stuff. On both of those instances is the Inspector agent. I've already installed it, I have configured that. I'm going to assume that you guys are happy looking at the Inspector pages to install the agent if you want to do that. It's simply installing packages or putting it in the user data when you start these things, so they're installed by default. I create a deployment assessment, and I make sure that anything marked staging or has the role web server is part of my assessment. That's why I showed you the tags earlier, because it's how Inspector works. It pulls in groups by their tags. You then create an assessment template. An assessment template is something that says which rules are relevant to this test. How long will the assessment run for? And in this case, I just selected every rule. I'm going to have the assessments run for 15 minutes because I believe I'm going to run a series of automated tests in that time, and 15 minutes is what I need. But you might run a considerably longer series of tests or do stability things and want longer. Here I look at the instances that are part of this. I've got two instances which are key. And you can see just there's two instances. That's all I'm trying to show there. Nothing too crazy about that. So I now create my assessment. So at this point, that is ready to run. If I clicked run at that point, it would begin assessing. But what I'm actually going to do is show you the automation piece to this. This is the cool bit. So I'm going to use an SNS topic from this. And I already have one called Assessment Complete, which I set up earlier. And here are the events. I could respond to several events, but the only one I care about right now is when the inspector run finishes, when everything has been done. And so when that run finishes, it will call that SNS topic on your behalf. Okay. Right, so what I'm going to show you is the other side of that topic. So I have a Lambda function the other side. I have assessment staging to prod. Should give you some idea of the fact this is a production step from the staging. And in here, I have set up a trigger. And the trigger is, when I get the SNS topic assessment complete, call this Lambda function. So I have no server behind this. This is the cool bit about using Lambda. I have some environment variables at the bottom that I give to this function. And I have, when I successfully run, add this security group, remove that security group, and this one is the internet-facing security group. So if I successfully pass, add this security group, and remove the VPC one, because I actually want to be on the internet rather than just within my VPC, and change the tag to a production tag. because I'm no longer in a staging place. So, in order to do this, I'm going to walk through the code for this. Again, this is Python. So we have the Lambda handler, which is the main function. I create EC2 and inspector for this as things I can access. I then load in the SNS message and pull out the run part of that, because obviously I care about which ARN is responsible for the run I've just done. I then have a function which counts how many high severity findings were there within that run. If there are none, I get all the IDs for the agents that were part of that run, and then I promote them into production. So if there are no high findings, I will make these changes on their behalf. So in this way, I use inspector to then list the findings, get me all the high severity findings, and return the number of them out from there. So that's that function that you saw a moment ago. I then get all the IDs. Again, that's how you do this, sort of with inspector. And promoting the instances is kind of fun. So here I create the tags. So I push the environment success tags. I build that list of add and remove, and then I've changed the security groups for the instance. So in this way, I've successfully promoted something. But I will only do this if there are no high findings with that Lambda function. Bear in mind, there is no server behind this. You've not had to run a script to promote anything. This is done for you with Lambda. So I now actually run the assessment. Now, I'm not going to make you wait 15 minutes for this assessment to run, because I figure your time is valuable, and you don't really want to sit here looking at a screen. So because I can do this, because I recorded it before I completed it. Now, it completes with errors because I actually cut it early. I did not let the assessment actually finish. In a normal case, that would not be the way. But it has completed, and I do have findings. So bear with me for the sake of demos. Here, I have 3 high findings. Those high findings obviously mean I will not deploy. But looking at the high findings, what I discover is, here is a vulnerability. It's explained to me in the blurb for that and what I should do about it in Inspector. The next one is another vulnerability. And again, in both cases, it's saying update the patches for the machine, update the kernel patch for this machine, because both of those issues relate to kernel things that are unpatched. In the last one, I have OpenSSH. Please patch this. Please get that up to date. And all 3 things are linked to the exact same root. Patch your box. Nice and easy one. That's why we looked right at the beginning about patching, because quite often that is one of the most important things to actually do to increase your security profile. So I'm just going to prove that those instances have not changed. I'm just going to step on the other side of this and show you those 2 instances again and show you that they're in exactly the same state they were in before. They did not get promoted to the production stack. There they are. The security groups are the same. Nothing has changed. The tags are the same. Nothing has changed. Same is true of the Windows box. I'm being fastidious about this because I want you to understand that the Lambda function is working and doing what you expect it to do. Now I'm going to log into the box. It tells me I've got 6 patches that I should have applied. I'm now going to update that box. Of course, I forgot to write sudo in the demo, so I had to step back. So again, we install these patches. The box is now coming up to date. We're increasing our security profile on the machine. Now, in most cases, you will need to do your tests, your integration tests, make sure your baselines are okay. But in this case, I have a very, very, very simple application, and I'm okay. So the patches are now installed. What I'm now going to do is obviously switch back to Inspector and make the next natural thing, which is get it to work for my application. So still has the 3 previous important findings, but I don't need to go recreate everything. What I can just do is just say run it again. Now, normally I would do this from an API as part of my continuous integration stack, but again, for the sake of demos, I'm showing it to you live. And this runs. And again, I'm going to cut this short, so we'll see completed with errors. This does not mean there is a problem. It just means that for the sake of cutting this short for a demo. So in this case, I have 8 findings. But as we look at those findings, none of them are high. So behind the scenes, the Lambda function will have executed on our behalf, will have found no high findings, and will have promoted those instances into production. So if we go and look at those, what we have is, look, we have web-internet, which was that add security group. We removed the VPC one, and we retagged it as production. And we did all of that with no server via Lambda as part of your step, which is pretty cool, or at least I think it's cool. So we did exactly the same with the Windows box. So here's me connecting to the Linux box. It's now on the internet. Nginx can see that. What about the Windows box? One moment later, there we go, IIS. So we have taken two instances, tested them, made sure they're patched, and then shown that we can put them on the internet using Lambda and check Spy Inspector on the way through, which is kind of cool. Anyone agree with me? There's some nodding heads. Good. Excellent. So, next I'm going to take you through what happens when you want to do something more dynamic to your application. What about when you want to pen test the application? And for those of you who don't know what pen testing is, it's penetration testing. I would like to go and try to push at my service. I want to see if I can take the edges on that service or send arbitrary content or scan it in some way. We have a very specific request process for this. And I'm going to point you at that URL because that's where the full detail of that is. But if you are not sure whether you need to do this when you're doing your testing, go and look at that URL, and if you're still not sure, file a request. It is absolutely reasonable that you should test your services. That is not an unreasonable thing. So following that process is the key thing. But I'm going to bring you all the way back to this baseline that we started with. We spent all that time with a threat model. We have all these things that you want to test. Have you done all of that with your source code check-ins? Have you done all of that with your deployment checks? There will still be some things you need to live test on your service. And this is where this really comes in. So, unless you're a security engineer, the next thing I'm going to say is probably one of the most important things when you're going to do security testing. Know your tools. There are lots and lots and lots of security tools out there that do a wild number of claims. Unless you're able to assess that yourself, you will need to make sure you know those tools, because you're going to take arbitrary code written by somebody else and test your service with it. So really do know your tools. The other side of that is most of those tools are not cloud aware. We can be really clever and selective with cloud APIs. I can tell you exactly what security groups are with these things, so what ports are exposed. I can tell you how this thing is configured, what it is supposed to do. And so most of those tools are not aware like that. They will try and spray packets across everything, every IP and every port. That is not what you want here. We can be very clever and very selective and only do the most surgical things that matter to us. So be cloud savvy and aware of what you could be doing here when you're running these tools. Okay. What I'm now going to show you is enumerating the internet endpoints. So I'm going to look at the ports that are available to the internet for these instances. And I'm going to look at whether they really are available to me. I may have security groups configured, which tell me I've got a range of ports, but which ones are really available? How would I actually do the beginning aspects of port scanning in a good, clever way? So I have a final demo for this, which I'm going to show you now. So I wrote some scripts to do this. Again, more Python scripts, and I apologize for those of you who do not like Python. You are forced to like my languages of choice. So I have a scanning script that uses the tag here to keep this constrained to only the web server, again, being selective, and builds up a targets JSON file, which I'll show you in a moment and explain. So this has enumerated every single security group, looked for all the internet-facing ones, and then looked for all the instances that implement that security group with the same tag name. So we've built a very selected, very small list of targets. We said, these IP addresses that match this, these ports that are actually open to the internet for these instances, which is kind of cool. I mean, most times you would go, well, here's a list of IPs that meet my server farm. Here I've just shown what this JSON file has. So the first instances are Linux web server again. The security groups give me 80, 443, and hang on, oops, 22. Did I really expose that to the internet, guys? And then the same with the Windows instance, 80, 443, and the remote desktop port, 3389. Whoops, again. So what I've actually done is I've left my admin ports focused on the internet for these machines. Maybe that's not a good idea. So what I actually want to do is check. So the security groups allow it, but did I actually do this? Did I really configure it like that? So that's the next natural step. This is where port scanning or other aspects of connection would come in. So during my demo, I wrote a very, very, very simple port scanner, which I'm going to show you. It is really, really, really not the way you should implement a port scanner, but it's to show you what is capable of being done. Again, much like my source examples. So before that, I'm going to walk through the scanning script that I showed you. So here I have a discover option in here, and that discover option is the one I'm going to walk through as a function in a second. So if we go and look at that now, the discover function is, we build this filter of tags first. So we're only dealing with the tags that I care about in this case. We build the arguments to the session, we create it for EC2. I then get all the security groups underneath that, and I go through every single security group now in a loop. I look at the rules for those groups, and you can see I've now built which from and to ports there are. I then look for all the internet reachable ones, so all zeros. What is reachable from the internet, from anywhere? And if it's reachable, I then call the instances, find me the instances that match this filter. So I found all the security groups that could possibly be internet reachable. Now tell me all the instances that have those security groups. Because like quite a lot of people, you might have several security groups that are not implemented somewhere at the moment. So this is, tell me actually what really is implemented. I then build that into the JSON file that you see and emit that from the program. Okay, so again, nothing crazy, but we're using the APIs, using the logic within the service to be selective and give us what we need. And so I then feed this on to the port scanner that I'm going to show you in a moment too. Actually, the port scanner is a Lambda function. So I connect to Lambda with a function called connectScan. I give it my JSON file payload. I create an output file, and on we go. So that runs. That's going to look at both IP addresses and all ports that we were part of that file. And that completes successfully with a 200 code. As most of you know, that's okay. That's good. We now look at the output file and chuck that through. And we can see indeed that ports 80 and 22 are open to the internet. Oops. And ports 80 and 3389 are open to the internet. So yes, I really have left my admin ports facing the internet on these boxes. Maybe as a security engineer, I should do something about that. So what does that code look like the other side of this? I'm going to say again, do not implement it this way. There are cleverer ways to implement port scanners than this, but this is for the sake of a demo and showing you the art of the possible rather than the best way to do it. So I walk through that targets file. I pick up the instances and the IPs for that. I then walk through each port within that, and then I simply connect to it. I just open a socket up to it. Simple connect, normal TCP thing to do. If I successfully connect, so if the result is a success result, I then build that into my output file. And I append it, close the socket cleanly, and then build it into that file which comes back. Now again, we've used Lambda to do this. There is no special server architecture here. I've asked something to do it on my behalf, rather than I have to spin up architecture. Now that's kind of fun too. We've just created a security tool in Lambda, which I can call with selective targeting. Bear in mind that you can do really a lot more with this. Let's consider your web application has got directories that should not be exposed. Maybe you have an admin section that's only supposed to be accessible from a small number of ports, and you want to confirm that. Well, using the same idea here, you could use Lambda to do that too. So the point that I'm trying to get you to is you can think very differently about these checks, how we make sure our security baselines work, how we do our business of ensuring our applications really meet the threat model we actually started with, to bring us all the way back in a full circle. So, here's kind of my call to arms right at the end of this. In the end, this is really about continuous security. What we're really trying to do is integrate testing the whole way through, automate the whole time, ensure that we do not fall backwards in the security state of our application. So this is making sure that it's absolutely easy for people within the business who are not security engineers, who are not administrators, to all gain the benefits of each other's experience. And so hopefully I've walked you through a number of things, be it understanding patches, checking the source code, deploying safely, or even actually scanning your stuff to show you how you should go through this process. It helps you answer your point-in-time questions as well. We need to be able to ask that of our systems and understand where we are. The piece that I haven't shown you in this is monitoring for the changes. How do we operationally run this? There are lots of other talks during this reInvent series that talk about the monitoring, how you use CloudWatch logs, how you use the alarms, how you use Lambda to prevent certain things behaving there. I focus purely on the proactive elements of this, as I promised I would. But the monitoring side of that is just as important, and it's the side of the talks that you should also build into this too. Okay. Thank you very much. Really appreciate that.